In this video, I will introduce fluorescent dissolved organic matter as a measure of water quality and describe how it can be used to indicate the presence of potential DBP precursors. Fluorescent dissolved organic matter, or FDOM, is derived from living things and contains carbon. It is not made of particles but is dissolved in water. The color in coffee is an example of dissolved organic matter. And importantly, if light is transmitted through the water, FDOM molecules will absorb it and emit a different wavelength of light. This is the process of fluorescence. FDOM sensors measure the amount of fluorescence emitted by certain types of organic matter. First, the sensor emits light at a specific wavelength into the water, and the light is absorbed by an organic matter molecule. Next, the organic matter molecule emits light at a different wavelength. This is called fluorescence. The difference in the light emitted and received by the sensor gives us a metric of the amount of organic matter in the water. FDOM is measured in quinine sulfate units, or QSU. QSU is an indirect measure that compares the amount of fluorescence emitted by organic matter in water to the amount of fluorescence emitted by a known quantity of quinine sulfate in a laboratory setting. Sensors are calibrated using QSU to ensure consistent readings across sensors and reservoirs. Fluorescent dissolved organic matter is a measurement of naturally occurring organic matter in water. And as we have learned, excessive naturally occurring organic matter can lead to DBP formation during water treatment. Thus, while FDOM does not measure all organic matter or all DBP precursors, it can be an indicator of the presence of potential DBP precursors. Recall from the introductory presentation that TOC, or total organic carbon, is one way that water managers can monitor for DBP precursors. Typically, TOC measurements of both raw and filtered water are taken once a month. High TOC levels can indicate the presence of DBP precursors, which may form DBPs during treatment. While FDOM and TOC are not exactly the same, we can use statistics to make a relationship that converts FDOM in quinine sulfate units to TOC in milligrams per liter. With this relationship, FDOM data can help us detect the presence of potential DBP precursors and assess DBP formation risk. The nice thing about this is that FDOM sensors often take measurements at a high frequency, many times a day, and these measurements may be available to water managers in real time. This can make FDOM measurements a useful tool to assess DBP risk, especially in comparison to TOC samples, which are often taken only once a month. In general, a reservoir may be at risk of experiencing water quality degradation due to DBP formation when FDOM is elevated. In the example figure shown on this slide, DBP formation risk is highest when FDOM is highest, because this probably means that TOC is also relatively high, and there may be DBP precursors in the raw water. This is the end of the video. Thanks for your attention.